Hello and welcome back, everyone. You may see this chasm and ask, why is there a chasm? Or why is the land slightly undulating? Unimportant. When I see a chasm like this, I see potential. And by potential, I mean we can build a bridge across it. Oh god, I accidentally dropped gravity. I accidentally dropped 2 gravities. How do I manage to do this every time? Okay, so support. The support is going to be built out of the river, and hopefully this doesn't collapse, because if my first support collapses, that would be kind of embarrassing. Kind of embarrassing. Okay, there we go. Balanced? Oh yeah, look at that. It's such a supportive support. It is slightly leaning. That's okay, we can just wait until it's leaning the way I want it to lean. Whatever, we'll start on the second one. I think we're gonna need 3 supports to span this. Alright. Oh, and if you build some bridges in this game and upload them to the Steam Workshop, perhaps I can take a look at them and we can see who has the coolest bridge. And of course, we're gonna drop things on them to test what they can handle. I mean, obviously. Alright. Ooh. That was scary. That was really scary. I was very scared by that. Alright. I could have just copied and pasted the first support, but that would make it too correct and not terrible. And you know my channel. Look, I do try to make cool things, but I also don't like spending 18 hours, you know, on them. Leave that for the people who really just love spending 27 hours on things. I like taking risks, like letting my supports hang out. Okay, so what I'm gonna do is I'm gonna hang something off the side of this to see if I can pull it. Oh my god, it worked. Okay, now we're gonna connect these supports together, and we are going to absolutely pray. Ah! Okay. Okay, perfect. Okay, now I'm going to connect this over to the ground over here, so it's kind of being pulled. Granted, generally you don't use the literal road surface to do this. Oh, it's definitely... Oh, no. Okay, stone may be too flexible for what we are doing here. Or maybe we just have to do it all in one go so that it's got a little bit of tension. I think ensuring the entire system is tensioned all the way through is going to be critical to making this work. So I'm just gonna kind of... I don't even think this is gonna be the road surface. This is just tensioning cables to kind of hold these equal. Okay, good. Good. So our supports are actually doing a really good job. The rain's a little annoying, but look at that. We kind of have it held together. Now we need a thicker, less flexible surface for the road, which is gonna be right here. I'm hoping I don't have to do any, like, suspension design here to make this work. But if we have to, I mean, it'll collapse if it... Well, that... I don't think it'll collapse, per se, but it'll be very unstable. And also, this game simulates weight, so one of the things you may be asking is, like, why don't you just use an absolute ton of material? Well, because using too much material will also be putting way more force on everything, and that could lead to very dramatic effects. Okay! You know what? The road surface is fine. It's flexing a little bit, but it didn't break, and none of the supports have broken, and the cables underneath are properly tensioning. Alright. I feel like this is gonna explode. Alright. much weight! All of that! Oh. Okay, so that's the limitation of only using one material, though. And a lot of you were probably watching this and going, well, why are you making it all out of stone? Obviously, in the modern day, we use metal to build bridges for a reason. Yeah, that's true, we do. So let's redo this, but with some improvements. Gonna get my supports back in here. I'm going to try and refill the ocean. I mean river. Ocean, river, same thing. What's the difference? Alright, there we go. Someone in the comments is going to write a very long explanation of the difference between a lake and an ocean, because they're going to think I have no clue what the difference is. But guess what? Neither is what we're talking about. We're talking about rivers. Got him! Got him. You forgot. You were going so quickly to correct me in the comments that you thought it was a lake. Rookie mistake. All right, so now we have steel, and you'll see it is so much less flexible. I mean, it's still got a little. Maybe I should just unpause before I say things. The game proves me wrong every time I say anything. Okay, let's let these noodles get back into their upright position, and then let's design this with a little bit more intelligence again. Okay, yep. Da-da, 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 da-da. The process they actually use in the real world to put these supports into the ground in the water is pretty crazy. You should watch a video on it. I don't know any videos off the top of my head, but they are pretty cool. Like the whole process of how they do it is pretty insane, so I feel like you guys would enjoy watching that. If you enjoy my content, then you'll probably enjoy actual engineering, maybe, even though what I am doing right now isn't precisely the most realistic. Woo! You know, sometimes this game scares me a little bit. Okay. We've got... Oh. It just it sags so hard. I guess I could change the material properties and make this a little bit more rigid. But I feel like that's cheating. You know, we gotta do this with default settings. Alright, so now we're gonna try to put the road bed onto this. If I can get it to be a little bit less, crazy. I wonder if I turn the C distance up to like 1.1, if I can make less flexible. And kind of do this. No, it's still pretty flexible. I just added weight. Alright, yeah. I don't want the extra weight. Let's cut the extra weight off. Okay, but we do have a bridge. Like, this is 100% a bridge now. And let's go ahead and put the road surface on it. See how that affects things. Also, the road surface does not have to be this thick. Like, we don't put 20 feet deep roads on things, okay? We can really, like, really thinify this. There's gonna be a little bit of water trapped under it, but that's okay. Water and asphalt never caused any problems, ever. Okay, so it is able to support the road surface, so that's good news. Do I want to build a beautiful suspension system? Of course I do. So we're gonna pray, and we're actually gonna use plastic for the actual cables, which I know in real life they're not plastic, but I feel like the lowered weight in this is going to help immensely. It would also help if these actually connected. There we go. There we go. All right, cables. Okay. I am praying that this does what I want it to do. Nope. 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 Yeah, it's best that we just don't try to do this with the cables. I need more materials which are better suited. Maybe in a V2 of the video, I'll design some better materials for that. But this is actually a pretty good bridge, so let's see what happens if there is an earthquake. That's right, a proper earthquake. How are we going to simulate that? We're going, actually, let me save this real quick. I'm gonna call it Bridge V1. Okay, cool. I'm gonna drop a giant meteor just over here. I mean, the impact is definitely going to cause the Earth to shake. You can't argue with that logic. And also, I'm gonna put me on the bridge. Always need someone for testing purposes. There. Oh, look at me! Let's go! Okay. So yeah, meteor impact has occurred, and holy moly, the amount of movement we're getting in the ground. Oh, okay, this is definitely worse than any earthquake. I just bounced off of the surface. Oh, holy moly! Oh, look at this! Oh, the road snapped, but the actual bridge, the metal did not. The asphalt broke, but the bridge is actually handling it. Oh my god. I did not expect it to survive that. Okay, let's try another one. We'll try it over here instead, though. Wow, it flexed a lot, and I think it may have taken a little bit of damage, but it wasn't enough to actually break the bridge. Okay, shake. Oh! Look at the force go through the bridge. Oh man, but it's actually holding up. I'm just bouncing over here. I'm breakdancing. Oh man, that's really neat. That's really, really neat. Okay. That's working way better than I thought it would. Let me think of another way to simulate. Okay. I'm going to lift the ground over here a tiny bit. Wrong way! Wrong way! Oh! Oh no! Pieces of dirt. Oh god, it's rolling over! It's rolling over! I didn't mean to do that! Oh no, is the stone gonna come all the way over? No, it didn't. Actually, that would have been kind of funny though. I meant to rotate it the other way, this way, like that. Yeah, and go frame by frame. But honestly, even things that are breaking the literal ground are not breaking our bridge. Our bridge is very strong, although the actual road surface has broken and it's covered in debris. The bridge is fine. Okay, we kind of want to see it now. I mean, oh, it just exploded. Whoops. Oh yeah, there's several asteroids that are about to hit the bridge now. Let's see what happens. Okay, the first impact just bounced. I don't think it's surviving this. I'm sorry. It's also going to hit me, so I'm not surviving this either. So, yeah. Say goodbye to your maybe favorite YouTuber. Oh, my legs. Okay. The force is being transmitted down to the actual support really well. Oh, man. It's flexing. It's flexing. There's so much weight. Oh, there we go. It's snapping the concrete, but the metal core did not. I mean, it's weakened, but oh my god! Oh no, there's an even bigger one! Oh! I cannot believe this. I cannot believe this. I died, but the bridge did not. It is so strong. Wow. Now we just have a new road surface made out of asteroid remains. Alright guys, there's only one more way to test this, really. We're gonna drop something directly onto the bridge. There's no way. There is a 0% chance that, especially after it's already taken damage, that it survives this. This is just way too large of an object. This is absolutely massive. It's a third of the size of the bridge, okay? Alright, here it goes. Initial impact. Didn't snap anything yet. That center support. Ooh, that column is not looking good. Oh, the stone is tearing. The rest of the bridge is getting pulled in. The metal has no— oh, the metal sheared. The metal sheared off in the center. Okay, yeah. Oh, and all of that elastic energy just flying out after. Oh, that was beautiful. Okay, that was good. I really liked that. Is there anything else we can do with this bridge? I'm trying to think if there's any other tests I wanna do on it. I kind of want to roll something across it after last time. Like if I get a little ball and I just roll it. Surely I can get it to act like a wheel. It's not getting any grip. Come on, friction, do your thing. It's having a little bit of trouble, but I can help it. Here we go. Here we go. Oh yeah. Rolling along. Rolling along. This is actually a great test because we actually get to see how the bridge handles the force moving across it. Although the object is having a hard time actually gripping the surface. Here, I'm gonna move it along a little bit, see if we can get it moving again. There we go. There we go. There we go. There we go. Come on. You can make it the rest of the way. Good thing this game doesn't have sound. The sound of rock grinding on rock and metal would probably have driven us insane by now. It's actually making sand. Oh, oh, oh. I wonder if I make this a more aggressive oblong shape, I might have an easier time. If I make it into a stick. Yeah, I know, it's not a wheel anymore, but I think it'll have an easier time traveling. It's just gonna kind of hop along the bridge. No, it's still kind of stuck. Oh, no! I mean, it's okay. It's fine. The last thing I want to simulate. This is an important one. What if a volcano were to erupt under the bridge? See? You didn't think of that one. This is something every bridge engineer needs to be ready for. The possibility is there. It's happening. We have the volcano. The volcano is mentally prepared for this. It's doing well so far. I'm gonna give it credit where credit's due. Oh, oh. I'm gonna try to actually move this up a little bit more. There we go. Now, the first warning should be that the river is turning into steam. Actually, that may help hold the bridge up because the steam is pushing up on it. I didn't even consider that. Okay, as we add more lava, the bridge is getting taller. It's getting more impressive. Some would say it's a good thing. Oh, the volcano is beginning to erupt. Okay. I mean, this is definitely going to affect stability. But so far, it's doing a really good job. Yeah, even with a major eruption, it's just kind of chilling. And like I said, the steam is actually helping to hold it up. Impressive. The only issue is that it now has to contain literal lava because this is a two-dimensional world. How much lava can it contain between the two spans? I mean, there's got to be an upper limit before it just snaps, right? It can't do this for... I mean, I guess technically the lava could find a path of less resistance, but this mountain is pretty heavy. So I feel like the easiest way to escape is going to... Oh! No, it just went over here. Technically, the bridge is still functional. It's just now holding a lot of lava. This feels like another video I made recently. You should go watch that. Okay. There it goes! Finally, it snapped. Alright, guys. Thank you for watching. Leave a like and subscribe if you enjoyed. This was a fun one to make, and I'll see you all next time. Bye!